So continuing our video on the sine and cosine functions, here's some more examples of unit circle using special angles. Now the two angles we're going to talk about, or the two special types of triangles, are a 30, 60, 90 triangle. Which is a triangle that looks like this. This would be 30 degrees, 60. And in the case of what we're using with the unit circle, our radius will always be 1. Therefore, by definition, the side opposite to 30 is half of that hypotenuse, which would make this a half. And the side opposite to 60 is that short side times the square root of 3. So it would make that the square root of 3 over 2. In a 45, 45, 90 triangle, which is an isosceles triangle. And again, if that radius is 1, because it's a unit circle, then each of these sides opposite the 45 degree angle would be square root of 2 over 2. So basically we need to just understand that if the radius is 1, which it will always be when we're dealing with trig in the unit circle, the side opposite of 30 is a half, the side opposite of 60 is root 3 over 2, and the side opposite of 45 is root 2 over 2. So to determine the exact values of these, of sine and cosine, so if I'm asked to find the sine of 45 degrees, I would draw a 45 degree angle, which is about there, and always drop down or up to the x-axis. That forms a 45, 45, 90. This is 1, this is the unit circle, and as we just said, both sides would then be root 2 over 2. Alright, it's imperative to know that we're going right and we're going up, so both of those are positive. We're finding the sine of 45 degrees, so that is the y coordinate, which is root 2 over 2. If I'm asked to find the cosine of 120, again we rotate from this terminal ray, 120 would be about right there. I drop down to the x-axis, and if this is 120 degrees, this has to be 60, and this would be 30. Side opposite to 30 is a half, side opposite to 60 is root 3 over 2. I am finding cosine of this, which is the x, and there's the x coordinate. That's going left, so this would be a negative 1/2. Sine of 5 pi over 3. Pi over 3 is 60 degrees. I have 5 of those, so this is sine of 300 degrees. So I'm going to rotate from this terminal ray. That's 90, 180, 270. 300 would be about there, and it would make this angle 60. This forms a 30, 60, 90. Side opposite 30 is a half. Side opposite 60 is root 3 over 2. Sine is the y coordinate by definition, and the y coordinate is root 3 over 2, but that's going down, so it needs to be negative. Find the graphs of these sine functions, cosine and sine. Very important you use the unit circle. And remember the points on these. This would have the coordinate 1, 0. This point would have the coordinate 0, 1, negative 1, 0, and 0, negative 1. So when we graph these, we can scale the x-axis by the angle measure, 90, 180, 270, 360, and then it'll go 450, 540, going the other way, negative 90. So basically we're rotating around this circle, and we keep rotating. So the sine of 0 degrees right here is the y coordinate. That would be 0. The sine of 90 degrees is right here. that y-coordinate is a positive 1. Sine of 180 is 0. Sine of 270 is negative 1. Sine of 360 is 0. And then it's going to restart. And keep repeating the same pattern. So my sine graph would look like this. It's beginning at 0, never higher than 1, never lower than negative 1. The cosine. So doing the same thing, but now we'll talk about the x-coordinate. So we start here again, and the x-coordinate is 1. And then we go to 90, where the x-coordinate is 0. Then 180, where the x-coordinate is negative 1. And then 0. And then 1, back to 0. And the graph of cosine would look like this. Starting at 1 now, never getting higher than 1 or lower than negative 1. And the same basic shape as the sine graph.